Now we're going to talk about alternative energy. One of the things we're going to talk about is what are your options now for wind and solar power. We're also going to talk about what changes we do to a house to accommodate those. It's very important that you make an energy efficient shell so you can use those power sources effectively.
So we're going to talk a little bit about energy concepts, basic ideas of what is energy. I'm going to go over some basics of how solar power works, what's involved in the technology, give you guys a good idea of what we're looking at. We have all sorts of energy available to us on the earth without digging old stuff up. The sun, the earth, water, wind, and we are a renewable resource. So my idea to reduce our fossil fuel, or to actually get to zero fossil fuel consumption, we're going to need to use a variety of other inputs, not just one. So wind, solar, hydro, biomass, and maybe fusion if we get there. But the most important piece of this whole puzzle is us. We have to put the energy forward to do this stuff, to get away from these old processes. This is what you see on typical rooftops. Commercial areas will be these ballasted rackings that are slightly tilted. We're starting to see some bifacial modules that let sun all the way through. They can be used as awnings or walkways. Really neat application here. And I believe that's just a carport parking area that also produces power. I think that's a bus stop in like Japan or something. But some neat applications for this stuff. Because it's modular, it's panel based, we can build anything with it. So you don't just have the panels. There's some other components involved in getting usable power out of our system. The PV and the wind both produce DC electricity, direct current, which is just a flat line of electricity. Most of our appliances in our buildings use AC power, alternating current. So in order to get the DC power to AC, we have to use what's called an inverter, which takes that energy and makes it something usable we can use. So this is typically what you'll see as the balance of systems for an average system. This is actually a grid-tied system with battery backup. When you introduce batteries, I don't really like batteries that much. They're much like people. If you don't work them enough, they get lazy. And if you overwork them, they get tired. And if you're not really taking good care of them, they'll break and they won't do anything for you. So if we introduce batteries, we have to have a boss or a controller to take care of these dummies. So we'll have to put in a charge controller, which regulates the amount of voltage, the amount of power, and keeps your batteries as happy as they can be. So what you see here is you have an inverter, your charge controller, which is tied into a distribution panel that goes to their house. When power goes out at this place, the gentleman comes out here and turns this switch off. It initiates the batteries or brings these dummies online. The system kicks back on, he's able to produce power again. So it's not just the panels, there is some other components we have to think about when we're doing solar, and you want to have a nice environment, controlled area for these components. A nice tool that we use is called the Solar Pathfinder. And what this does is they have different sun charts for different latitudes. This is for our latitude. It will show you the sun's path across the sky in any given month throughout the year. So we can actually take this to the physical site and we put this little dome over top, which is shaped like the earth. So what this does is it shows us a reflection of anything around, and it shows the path of the sun that it would take. So you can see at this site you're going to have a tree here that's going to shade you in the morning. In most of the year you got this pesky little house that's going to shade you in the winter. And this would be an okay site, but usually you want to see no shading. That's ideal. But what we're looking for to make sure a site is viable is we want no shading between 9 a.m. and 3 p.m. throughout the whole year. That's our window we're looking for optimal. But this is a tool that actually lets you quantify the exact amount of solar resource you're getting in an exact location and pinpoint on your property what's the best place to put your panels. So again, every dollar that you spend on efficiency is going to save you 3 to 5 when you come to produce your power. You need a good southern exposure to use solar, and batteries reduce the total system efficiency, so avoid them if possible. Grid tie if possible. So what is wind power? Well, Wind is nothing more than the sun moving air. The sun radiates energy to the earth, heats the air over the land, or heats the land, which heats the air around it. The warm air rises, and the cool air moves in to take its place. That's wind. Wind's created by the sun. So, swept area. So we see the density of air. The swept area is the actual area of the blades, or the rotor diameter. This can be controlled by the size of the turbine you buy. And the velocity is, again, cubed, the most important factor here. We can control that by height. But I just want you to show you the theoretical production of any given size wind turbine based on swept area. This is in meters, so you have to do the nice conversions to get it to feet. But I just want to show you that a 1 meter, 3-foot diameter turbine only has a theoretical capability to put out 0.4 kilowatts of power at any given time. You can kind of use this chart to rule out good turbines and bad turbines. You'll see a turbine on eBay that's 3 foot wide. They're claiming it's a 2 kilowatt machine. Well, you know it's not even possible, and you can rule out buying that turbine altogether. This is a nice tool to judge if the turbine or the manufacturer is actually giving you real information. The biggest component that we can control in the wind turbine is tower height. That's how we get the turbine up into more wind speed. Just to show you here, if we go from 12 miles per hour at 30 meters in this example, and we double the height of our turbine to 60, we increase by about 1 mile per hour and a half. Increases your power by 40%. If you go up about 3.5 miles per hour, or 4 times that height, you're going to get 100% more power out of the same turbine. And this is a variable that we can control. So the tower is the most important part of your wind turbine, period. The higher you put it, the more power you're going to get, the more efficiently it's going to produce, and the less wear and tear you're going to see on your machine. So all those factors make your tower very important. Not to mention, the higher up it is, the quieter it's going to be. Because the wind turbines will produce noise just like anything spinning around in the wind. Tower is the most important factor. Unfortunately, it's also the factor that's limited by politics and zoning. So we got to kind of balance the pros and cons there. Well, we're seeing again the vertical axis wind turbines. Those remain to be tested. And then you have your big wind turbines, commercial scale turbines. I will say something about these. I have to. I can't resist. I can't resist. The issue these have, they're very cool looking. The issue they have is versus their counterpart, which is the horizontal turbine, you don't have nearly the swept area that you have with this machine. And this turbine is fighting itself when it comes back into the wind. Throughout the last, 30, 40 years, they've been working on this design. We've only seen about 45% efficiency come out of these turbines compared to their counterparts. So usually they're higher price and they're not as much power in actual production. So I really like the new stuff coming out. I hope that they're getting that worked out because I like the way they look. They're a good application for the city, so I'm rooting for them. But we'll see how it goes. So that's pretty much all that's involved in the components of a wind turbine. Most of this stuff's engineered by the manufacturers. They include their inverters, the tower packages. You really don't have to do a lot of mix and match of components. It's pretty much straightforward. So the thing that's most important is how do you determine your wind resource for your site? Well, there's a few ways to do that. We can use wind maps. We can use meteorological data from the weather stations, the airports. We can use what's called the grid's Putnam index, or we can actually use an anemometer to measure the exact amount of power or wind speed at any given location. So this is kind of what a wind map looks like. The Iowa Energy Center is a great resource for all this stuff. They've got tons of data and they're excellent. Most of these maps are done at 50 meters above the ground, so keep that in mind. It's 150 feet or so above the ground. Usually we can't get up into those winds, so we want to come down in our numbers here. But we can see most of the state of Iowa gets about 14 to 15 miles per hour average wind speeds for the whole year. Gets way better as you go northwest and not so good as you move toward Illinois. But we have one of the best resources in the whole country. Per square foot of usable area, we have #1. So we have an excellent wind resource in Iowa, and that's why you see tons of wind turbines going up. Well, a more exact way to get an actual wind estimate or average wind speed for any given site is to use vegetation. These trees, usually the coniferous trees, grow all year round. They've been up for 15 to 20 years. And what happens is when the wind comes from this side, if it's consistent enough, it will slowly push the new growth downwind. It's just natural. And as you see the wind speeds pick up, you'll see more and more substantial deformation of your vegetation. And the coniferous trees are the easiest to tell because they have leaves during the winter, which is our windiest time. They have needles, excuse me, during the winter. So they're going to bend more during that time. And it's natural, it's beautiful. So usually you don't need an anemometer to quantify a wind speed at a given site if you can observe nature. And these are just some examples of wind speeds. The neat thing is, if you see a tree like this on your property, and it's 10 to 13 miles on average to deform this tree like that, your wind speeds above that are going to be incredible. So if you see trees like that, you want to start thinking maybe about doing a wind turbine. This one was taken in Colorado. You usually won't see that in Iowa, but that's an extreme situation. As that wind approaches an obstacle, it's going to create a compression wave here, which is going to push all this air up and over, and it's going to swirl around and then slowly become placid again. What we want to do is we want to get up into this smooth wind stream. You're going to get more power more often, and it's going to be less violent or less turbulent. If you put a turbine down in this turbulent area, you're not going to see good power. We need continuous power to make wind turbines work. And if you put it down here, it's not going to know what to do. It's going to be getting all sorts of different angles, and it's really not going to perform well. It's going to shake the bearings up, and you're going to have maintenance issues. So usually you want to pick sites that are conducive to this. You want to put it on the dominant wind side of any obstacles, or you want to put it about 30 feet higher than any obstructions. I like to double the height, might as well. The higher you put up a turbine, the better it's going to produce, the less maintenance and the less worries you have, and it's quieter. Another way, which is usually more productive and reliable, is to make a hybrid system with all these technologies in. No matter what the weather is, you're going to be producing power. If one of your systems goes down, you've got something else to produce energy. Similar way it operates, your panels go through an inverter to your service panel. Your turbine, which has the inverter actually built in this one, will go through the inverter into your panel. Those things will look for energy to do in your home first. If nothing's going on, push back through your meter. There's kind of a natural ebb and flow to our resources. Hold on. In Iowa, and typically in the spring, the summer, and the fall, we get our best solar resource, but our worst wind resource. The opposite is true for the fall, the winter, and the spring. We see a more wind resource, but less solar. So there's an ebb and flow, and I like to kind of diversify your investment.